if I have angles like this, we would say in this particular case that angle 1 and angle 2 are adjacent. Now, adjacent angles, whenever we use the word adjacent, it's a very informal definition, but it helps me remember. They're touching. Okay, so angle 1 is right next to angle 2. And they are touching. The next example that I'd like to point out, can I move to a different screen, or do I gotta give you a second? I'll wait a second for you. Can I go now? Okay. So now another type of angle, if I go like this and like this, then we would have 1, 2, 3, 4. Now, when you have two intersecting lines, we would say that angle 1 and angle 3 are vertical angles. And what that means is that angle 1 is right across from angle 3. We could also say that angle 2 and angle 4 are also vertical angles. Okay? All right. Can I change the screen yet?
Yep.
Yeah. Okay. So now another type of angle that we could talk about is if I have a 90-degree angle, so and I'm purposefully drawing this kind of weird like this. Okay, we know that's a 90-degree angle, right? So now, if any angle, so this right here is what we call 90 or a right angle. But if I were to come in there and draw another angle, in other words, I've got angle 1 and angle 2. If angle 1 plus angle 2 equals 90 degrees, we would call those complementary. Angles. They add up to 90. Now the reason we do this is because sometimes we deal with right triangles, and that's why I use this example of a right triangle, because I wanted to show to you guys that a right triangle will always have a 90-degree angle, and that comes into play a lot. I don't know why we like 90 degrees, maybe because 360 degrees is a full circle. And when we build a room, which is a rectangle, there are 4 90-degree angles. So we use a lot of 90-degree angles in construction. Okay? And when I mean construction, I mean geometric construction, which is really kind of where construction comes from when we talk about building buildings, right? The word construction refers to how we geometrically lay out the building, not people hammering things. That's where construction comes from. All right, so who wants to guess what the next thing I'm going to draw is? Well, let's do it this way. What's the angle from here to here? 180, right? So if this is angle 1 and this is angle 2, and we say that angle 1 plus angle 2 equals 180 degrees, what do we call that? No, complementary was when they add up to 90. Supplementary. So we would say that they are supplementaries. which is that's a unique case. We're concerned with making sure something's a straight line, and so if we have an angle, sometimes in geometry we want to make sure that the next angle we add to it is equal to 180 total. So they're supplementary. So now let's jump into our actual example number 1. So our actual example number 1, we have a diagram that kind of looks like this. We have a couple of rays that share a common endpoint. Okay. And then over to the side, we have another diagram which is a little different. So this is A, this is B, this is C, this is point F, this is point D, and this is point E. And what the textbook is reminding us, and these are completely, they're trying to let us know something. If you zoom in on this, B and C and D and F, if we look at just this section right here, your book is reminding us that these have a common interior points. And that's a fancy way of saying that they all share the point F. Okay? But now, they also give us some measurements. This measurement here is 62 degrees. This, bless you, this measurement here is 28 degrees. And this one is 118. Okay. God bless you. So it says, use the diagram at the right. Is the statement true? And so they have a statement that says, angle BFD and angle CFD are adjacent. So we went back and we defined that. Are they adjacent? Now we got to be careful, okay? So now watch this. I heard some people say yes and some people say no. It's a kind of a trick question, right? Oh, I should probably label this. This is D, right here. So now, what's BFD? Well, BFD is actually, it's BFD, right? And it's saying that it is adjacent to CFD. Well, Mr. Adams said they're touching. I really should have said they're touching against each other. Are those adjacent? No, the little more formal definition means that the two angles are touching, but they don't share common points. So because they share a common point, the answer is not adjacent. They have common interior points. So if we go back to our definition of an adjacent angle, I loosely and informally defined it as two angles that kind of butt up to each other. In other words, they share a similar endpoint. But if I were to label this A, B, C, and then this last one D, I would have the angle ABC C, and then the adjacent one, which would be angle 2, would be angle CBD. Now, while they have one common interior point, which is C, clearly A is different than D. Does that make sense?
Yes. So they can only have one.
So what they're talking about, and I'm trying to think of an informal way to describe it, but if I draw a picture, it's a little clearer. This angle, if I color this angle in, and I color the other angle in, you'll never have an overlap of color. That's a better way to describe it. However, if I go here, I've already colored in CFD in yellow. So this is CFD in yellow. And then if I go to color in BFD in orange, when I start to color that in, what's going to happen? I'm going to get an overlap. So when they talk about common interior points, if we were talking about two-dimensional space and time, and I wanted to arbitrarily choose points in between, well, because these two overlap, they share all those points in space. Does that make sense? Even though we haven't labeled a point in space inside there.
And that's the relation that makes them adjacent.
Yeah, they wouldn't share interior points. Does that make sense? So I wanted to be clear that when they talk about interior points, that it's not, this shares D and this one shares C. That's not really the issue, and those are different. If I go back here, maybe I worded it not the best way, but I think the coloring it in makes it, there's no overlap, right? So if I were to pick a point in space, like if this was an x comma y, and this thing was on a two-dimensional plane where this is x and this is y, and I picked another spot over here, at no point in time would they overlap. But if I go to the example they gave us, and I pick this spot here, well, let me change the color, and I pick the spot here as x comma y would exist in both angles, angle BFD and angle CFD. Does that make sense? Therefore, they're not adjacent. Okay? Now, there's some more questions regarding all this stuff. So the other question is, can I erase some of this information? Okay. All right. So now we got some more questions. Next question they have for us, angle AFB and EFD are vertical angles. So we're asked to say if that's true or false. Now, for that to be a vertical angle, what we got to do is we got to go back and say, well, what is a vertical angle? Well, vertical angles, you have the intersection of two straight lines, and we know they're straight lines, right? I just drew them, but remember that these have to, this is a straight line, and so is that one. I said it, I just didn't label it as such. I said when we have the intersection of two straight lines. So now when we go back here, we have to ask ourselves, AFB, that angle, and EFD, is that an intersection of two straight lines? Well, what they're saying is I've got this, right? And then I've got this. Is that an intersection of two straight lines? No. So it's not a vertical angle. 2. What was this? 28. What's this? 112 or 118? And this is A. Is that C?
Yeah.
A, B. All right, so one more question. Can I erase this? All right. Last question that they're asking us. It says that AFE, the angle AFE, and angle BFC are complementary. So let's highlight that. If the angle AFE plus the angle BFC, and I should really say the measure of these angles, so the measure of this plus the measure of that, if they add up and equal 90, then they are complementary. Right? So what's the angle of AFE? Well, AFE is from here to here. That's 62 degrees. The angle from BFC is from here to here, and that is 28 degrees. When you add those up, what do you guys get? 90. So we get 90 equals 90. Are those complementary? Yes.
Yes.
Oh, you guys are smart. Shall we move on?
Let's.
All right, let's move on to example number 2.